Alright, welcome back to the flipped classroom. I'm Mr. Stevens. Today we're going to be talking about section 2-7, which is absolute value equations. If you remember from previous years, absolute value is the distance of a number on a number line from 0. For example, the absolute value of -5 is a total of 5 spaces away from 0, so we say that it's 5. Positive 5 is also 5 spaces away from 0, so we also consider that positive 5. In algebra, we use absolute value equations quite a bit. So to give practice with it, we insert a variable. We need to find out two numbers whose absolute value will be 12. So what we know is that our answer has to end up being 12. We know that 12 equals 12 without even the absolute value sign there. However, we also know that -12, when it's inside the absolute value, becomes a positive number. So my answer for the absolute value of x equals 12 can be x equals 12 or x equals -12 in this problem. This problem's a little bit different. The absolute value of x minus 6 equals 4. What we're going to do is we're going to treat this just like a two-step equation. We need to try to isolate the absolute value of x. So what we'll do to isolate is we're going to remove our constant outside the absolute value. Using inverse operations of subtraction, I can remove it on both sides of the equation. And now I've got the absolute value of x is equal to 10. From here, I need to find two numbers that equal 10. We know that positive 10 will work. We also know that -10 will work. Because if I take the absolute value of a negative number becomes a positive number. Absolute value of 10 is 10. This should be our solution for this example. Getting into more of the difficult parts, we have the absolute value of x plus 3 is equal to 10. Now, the absolute value is already isolated. So what I'm going to try to do here is I'm going to try to find two numbers that I can plug in for x that will get me 10. We know that our answer can either be a positive or a negative because when it comes out of the absolute value, it will become a positive number. And here's our trick. We're going to go ahead and drop the absolute value signs. We'll have our original problem, and then we'll make the negative answer on the other side. What this will allow me to do is get both of my answers at once. Now, treat this like a two-step equation, only instead we have three sides that we're dealing with. So how can I get rid of a positive 3? I'll remove this using inverse operations of addition. I'm going to do this for all three sides of the equal sign. So instead of just a two-step equation like we're used to, we have a two-step equation, or in this case a one-step equation, but it's got a third side to it. Now what happens here, -10 and -3 gets me a -13. The x is the only thing left inside of the equal signs, and 10 minus 3 is 7. Now just to prove to make sure that this is correct, because I know that 7 plus 3 gives me 10. If I take this -13 and plug it back in, -13 plus 3 gives me a -10. However, when I take the absolute value, the absolute value of negative 10 is positive 10, and I have the solution. This problem here, just like a two-step equation, we're going to isolate my absolute value and then set up the problem just like we did with our last one. So right here I recognize that I have a 4 outside the absolute value sign, which can be represented as 4 times the absolute value of x minus 5 equals 12. Inverse of multiplication is division, so I'll divide 4 on both sides of my equation. 4's cancel. 12 divided by 4 is 3. Now from here I've got an absolute value of x minus 5 equals 3. Set it up as positive 3 on the right, negative 3 on the left. Notice I need to get this absolute value by itself before I set up my two cases. So in the middle now I've got x minus 5. I need to remove this minus 5. I'll use the inverse of subtraction by adding 5 to both sides. Negative 3 plus 5 gives me 2. My middle will dissolve down to x, and 3 plus 5 is 8. Now just to check and make sure, I'm going to take this 2 and I'm going to plug it back into my original equation. So I don't think this is going to work because I've got all kinds of different stuff going on here. I want to make sure that this is the right answer. Inside my absolute value, we'll treat this just like a PEMDAS problem where the absolute value is the parentheses. We'll do everything inside the absolute value first. So 2 minus 5 is negative 3. However, the absolute value of negative 3 is positive 3. 4 times 3 is 12. So the 2 works. The 8 I can do in my head. 8 minus 5 is 3. The absolute value of 3 is 3. 3 times 4 is 12. So my two cases for this problem, x can be 2 or x can be 8 for this answer. The last one, the absolute value of x minus 3 plus 2 equals 2. I want to try to get this absolute value by itself. So I'll subtract 2, removing the constant on both sides using the inverse of addition. Now I've got the absolute value of x minus 3 is equal to 0. I'll have a positive 0. And we really don't need to have our negative 0 here because 0 is the only option that we have. Add 3 to both sides, removing my constant. X should equal 3. Plug it back in. 3 minus 3 is 0. Absolute value of 0 is 0. 0 plus 2 still gives me 2. This is the correct solution to this problem. There are a lot of examples in your book under the section 2-7 for absolute value. I want you to go ahead and take a look at them, try some of those problems, be ready for class when we get there.